Ohm's Law Data Analysis. This presentation will help guide you through the analysis and using Excel for the Ohm's Law lab. So first of all, there are two parts, A and B. You should have separate data tables for each. You didn't have to put this column in because for part A, the resistance should be the same for all of them. Now, for the current and the voltage, you might have these columns switched. If so, you want them to be in this order with your current on the left and voltage on the right. I'll explain as we graph why. For part B, you can have it set up like this and we can work with it from there. Alright, so the other thing I want to mention is inside each of these cells with your data, they should only be a numerical value. Do not put your units in with these values. It will not graph correctly. Put your units in the titles. Alright, so for part A, we want to graph our current versus our voltage. So you want to select these two columns. You want to go to Insert, Scatter, and you want to choose the simplest scatter plot. You should get a graph similar to this. Once you get this, you want to right click onto one of the data points and you want to say Add Trend Line. And you want to set intercept to 0, display equation on chart, and display R squared value on chart. Once you do that, you'll have this, and you want to change the format, the layout, to this. Once you do that, you can delete this legend, bring this out over here, and this is your first graph. You want to go ahead and change your titles to match what you're working with. This is going to be the current versus the voltage, and this is your best fit line. This is your y equals mx plus b format. We just set our intercept to 0, so it's y is equal to 209,269. From there, we can graph our second graph. So let's go ahead and put this off to the side, and I'll show you how to do the next graph. For part B, you kept your voltage the same, and you changed the resistors, and you measured the current. And so, we can do this, our current versus resistance, and you can do this directly. You can do a scatter plot, and this is what it would look like. It looks weird at first, but this is fine. We can go ahead and set it so that we have our axis titles. You can get rid of the legend and go from there. So you can label these as needed. And remember, these are different chart layouts that you can choose. Now, the reason why I wanted to set this one as I did, with the current on the left and voltage on the right, what you'll notice is that your voltage should be on your y-axis, which means that your current is on the x. And the reason for this is for our equation. So here, this is Ohm's law, so V equals IR. And if we work with our y equals mx plus b format, so y is equal to mx plus b, and we've set our b to 0, so we can just say y is equal to mx. If we were to map this out, and let me go ahead and move this off to the side. And so now, what you'll notice is that your voltage is on your y, and here's where you have to be careful. In this case, our current, our I, is on our x-axis, which means we need to rearrange this so this goes over here, which means that our slope now should be our resistance. Okay, so going back to our Excel spreadsheets, when you look at this, so again, voltage is on the y, current is on the x, which makes our slope value, in this case 209,269, our resistance value. And if you look over here, in this sample data, the resistance value is 214,000, and our slope is 209,269. And so we can do our percent error calculation with this first graph. Let me show you how to do that. So in this case, our measured value was 214,000. Let me get to a marker. So we have 214,000. And our graphed value is 209,269. So this is percent error. So 209,269. Let me just check to make sure. 209,269. There you go. And so for our percent error, it'll be our expected minus our experimental over our expected over 214,000. This times 100 will give you your percent error. So that's going to be for the percent error for the first graph. And you will need that in your lab. Now, going back to our Excel. So this will be our other graph. What you'll notice is we can't get a good line out of this. And so what we need to do is we need to straighten the curve by manipulating our data. So let me move this out of the way so you can see what I'm going to do. So the easiest way to do this is going to be to select these two columns, to copy it, and then to paste it down here. Okay, and you'll see the reason for that. What I want to do is I want to create another column to the left called inverse resistance. And I will show you the derivation for this as well, just so that you can see what I'm doing. Now, what we want to do is we want to create a formula with the inverse resistance. So inverse just means 1 over. So I'm going to say this is equal to, this is for the formula for Excel, 1 divided by, I'm going to click on the resistance, and then I'm going to press enter. And this will automatically do the inverse of the resistance. I'm going to click on this lower right hand corner, and I'm going to drag that formula down. So now I have the inverse resistance over here and the current like that. I'm going to graph this as well, the same scatter plot, and you will notice that we have a nice line. I'm going to go ahead and choose this layout, get rid of this legend, put this over here, and there you go. So this will be our last graph, and let me explain this part to you. We are again going to start with V equals IR. So V equals IR. I'm going to rearrange this so that it matches our graph. And so if you think back to this, we had our current and inverse resistance. And so what I'm going to do is I'm going to move my resistance over to the other side. So V over R is equal to I. I'm going to flip the sides. So I is equal to V over R. And hopefully you can see where I'm going with this. Now I'm going to do it this. V and 1 over R. So this is still Ohm's law, but now it's written in a way that we can match it with our line equation of y equals mx. And so hopefully you can see that if we put our current on our y-axis, if we put our 1 over resistance on our x, then our voltage should be equal to our slope. So let's go back to our Excel spreadsheet. There's one thing that we need to change for this, and this is for the trend line. So we need to format the trend line. We want to set our intercept to 0. And here we go. And so if we think back to our equation, this should put your current on the y and our inverse resistance on the x. And if you look over here, this slope value should be your voltage. And so in this case, for this test data, it was 2.91, and the slope of our graph shows 2.8743. And so we can do another percent error. So we can do 2.91 minus the value, 2.8743, divided by 2.91 times 100, and that will again give you another percent error. So for this lab, you will have 2% errors, you'll have 3 graphs, and you will have 2, or you can think of it as 3 data tables.